Welcome back. In this video we are going to do Cloud Database Solutions Architect Test / interview questions. I don't know about you, but I've noticed that a lot of cloud DevOps SRE jobs are requiring more database knowledge. Ideally anyway, that's what the company is asking for. I even had an interview question once. Have you ever had a production incident where you have edited the database directly? That's something that they were looking for in terms of experience. I know that's crazy, but anyway, I don't think I'm a database expert. I know a little bit. I'm always learning. This is going to be a great test for me. So this is similar to test or interview questions. So join me as we read and answer these questions together. And I will share my thoughts and my reasoning. We'll read together the explanations. And before I answer, feel free to pause if you want. These questions are created with the help of AI. They are not copyrighted. That's been checked. And also, not perfectly phrased, the questions, kind of like a human being, just, realistic situation. Let's start. So question 1, what is the primary benefit of using a schemaless database in a cloud environment? Is it A, improved data integrity, increased flexibility in data modeling, enhanced security features, or faster query performance? For me, I think this has to be B. So like a schemaless database, a classic example is semi-structured data, like storing, for example, JSON documents, NoSQL database. And there is flexibility because it's basically just a key value store. There's no real kind of schema, fixed columns or anything like that. So I don't think it's got anything to do with data integrity. At least it wouldn't improve it. Security is nothing to do with this, and I actually think performance might be possibly not as good. I don't think it's as easy to index. So I'm going to go with B, increased flexibility. Let's see what the answer is. And I was right. Schemaless databases like NoSQL databases allow for flexibility in data modeling, enabling devs to easily adapt to changing data requirements. Question 2. In a microservices architecture, what is the most effective way to manage database connections? A. Use a single connection pool shared by all services. B. Each microservice manages its own database connections. C. Establish database connections on demand for each request. Or D. Utilize a centralized database connection manager. Interesting. I don't think I know the answer to this question, and I might have a lot of trouble guessing as well. So there's one that stood out to me that I don't think is going to be a good idea, and that was B. Each microservice manages its own database connections. I mean you can do that, but I have a feeling that there's probably a better way to do that. This one also, establish connections on demand for each request. No, I don't see the point of that. I'm sure there's overhead when you make the initial connection, so why you would make a new connection every time you had a request, I can't believe that's right. I don't know. Yeah, it's A or D, but I don't want to think about it too hard. I don't want to reinforce some logic that's incorrect. Let's just see what the answer is. Okay, interesting. B. Each microservice should manage its own database connections. It provides autonomy, scalability. Interesting. Okay. I thought maybe that there was some benefit to not reinventing the wheel with each microservice, so that's very interesting. Note to self: I want to follow up and check and read up more about that. Question 3: which of the following strategies is best suited for ensuring data consistency in a distributed database system? Okay. Is it eventual consistency, strong consistency, causal? I thought it said casual consistency, read your writes consistency. Right? I don't even know what C and D are. I am aware of what A and B are. So, and I kind of forget what the difference is. I know with eventual consistency, it's when you, for example, have some kind of like a read replica or a secondary or something like that, and it will eventually be consistent. So yeah, distributed database. So but I don't know when it's a strategy for ensuring data consistency. I mean they both ensure consistency, they just do it in different ways. So I'm not sure what the answer is here. Let's have a look. B, strong consistency guarantees all users see the same data at the same time, which is crucial for specific apps requiring immediate consistency. Okay, I understand what they're saying. Yeah, because if you only have eventual consistency, then some users are going to get old data. So, okay, I get it. I'm not sure I agree with the way the question was phrased, but I do understand this principle. Question 4. What is the primary function of a Cloud DB's services auto-scaling feature? Auto-scaling. To optimize query performance, to adjust resources based on workload demand, to ensure data replication, to enhance security protocols. Right, auto-scaling, scaling up and scaling down according to demand. It's got to be B. It's not A. That would be more like sharding or something. It's not D. It's got nothing to do with security. And yeah, it's not really C either. Replication is something separate to scaling. So it's going to be B for sure. Indeed. Auto-scaling dynamically adjusts resources based on current workload demand, ensuring efficient resource utilization and cost management. Yep. Okay, great. Question 5. Which of the following is a key characteristic of a multi-cloud database strategy? Multi-cloud. Use of a single vendor for all services. That doesn't sound right if it's multi-cloud. Dependency on a single data center. Distribution of data across multiple cloud providers. Or centralized management of all cloud resources. So, having databases on more than one cloud, well, it's not single vendor. It's not centralized management either. You're not dependent on a single data center. I mean, no, this wouldn't be the case even if you were with only one cloud. You would still probably have your database spread across multiple zones and therefore multiple data centers. So it's going to be C, distribution of data across multiple cloud providers. C. Indeed. Involves distributing data and service across multiple cloud providers to enhance reliability and avoid vendor lock-in. Indeed. Enhance reliability. Yeah, I don't actually know what a database multi-cloud strategy looks like. Is it like a kind of a hot standby that you can just switch over all the database connections, and the second one is always up to date? It's got replication going on. It's a replica. I actually don't know what a multi-cloud database strategy is. So, note to self: go read that up. Question 6. Which database technology is most suitable for handling large volumes of unstructured data in real time? Is it relational database management, RDBMS? Is it object relational database? Is it document store? Is it column and database? Okay. So, if you don't know, right, there's structured data, which is what you get, fixed columns, SQL type databases. There's semi-structured, which is NoSQL type, typically storing documents, and there's unstructured, which is none of the first two. It doesn't really, it's not like a database. You would just put it in object storage. So A is for structured data, SQL database, relational. C, document store, would be semi-structured, like JSON documents or something like that. What's a columnar database? I'm not sure what that is, if that's the same as A. And an object relational database. I don't know what this object relational means. That's something I've never heard of before. I'm going to have to do some research on that. But the object part is what makes me think that this is for unstructured data, like, just random image files or something like that. So let's have a look. 6, I'm thinking it's B. Oh, and I'm wrong. Document stores are designed to handle unstructured data effectively, allowing for flexible data represent and real-time processing. I don't know if that's true. Document store. In fact, I don't know exactly what they mean by a document store. I thought they meant semi-structured data, kind of NoSQL database. But this must be something else that I'm just not familiar with, and apparently it's for unstructured data. So note to self: I need to have a look at that. Question 7. In database replication, what is the main purpose of using a write-ahead log, a WAL? I've heard of this, but I haven't read this in literally years. Is it A, to increase read performance? B, ensure durability and consistency? Optimize data compression, reduce network latency? Right. So this is replication, and you have a write-ahead log. Yeah, this is This is write ahead log. You're writing ahead. I think this is something to do maybe with before you create the record, you're creating a log first, and that has some advantage. Something like that. I don't think it's read performance. I don't think it's network latency. I don't think it's I think it's this one, B. But I'm not sure. We're going to get the explanation now. Yes, indeed. It ensures that changes are recorded before they are applied. Indeed. So you write to the log before you actually even make the changes to the table. Yeah, I was correct. Which helps maintain durability and consistency in replicated databases. Indeed. I'd like to know more about this. I'm note to self. I need to have a look at that. Question 8. Which cloud architecture pattern helps minimize latency when accessing data from geographically distributed locations, so from different locations far apart? Minimize latency. Is it multi-region replication, single region deployment, centralized database architecture, data locality pattern? Okay, it's not single region deployment, because if you're nowhere near that region, it's not going to minimize any latency. It can't be C, because that's centralized. It's probably A, because we're talking about cloud architecture patterns, right? So replicate to other regions, and yeah, it would be eventually consistent, but at least you were still going to minimize your latency. I don't know what this is. D. It might be D, but I'm thinking it's going to be A. Let's have a look. Oh, it's D. Interesting. Data locality pattern ensures that data is stored close to where it's accessed, minimizing latency for users in different geographical locations. Okay, interesting. But I think, I think the multi-region also does the same thing. But clearly, this is a specific thing, data locality pattern. Okay, note to self, I need to have a look at that. I don't know how you fared, so let me know in the comments. Question 9. What is the primary advantage of using partitioning in a cloud database? Simplifies the schema, faster data retrieval and management, reduces the need for data replication, enhances data encryption. Okay, nothing to do with encryption, partitioning. In fact, I don't even remember exactly what partitioning is. Obviously, I know what the word partition means, and I'm used to partitioning when it comes to disks. And I guess it's a similar thing. So it's definitely nothing to do with enhancing encryption. I don't think it simplifies the schema. It might be B, faster retrieval, and reduces the need for replication. I don't think that's true. I have a feeling it's B. Let's have a look. Indeed. Divides a DB into smaller, more manageable pieces, which can improve retrieval times and overall performance. Indeed. It's a bit like defragging your hard drive, right? You're keeping contiguous data in its own space so that you're not having to retrieve from all over the place. So it's a kind of similar thing in that respect. And the same as if you partition your hard drive into separate things for separate purposes, then you're not making reads all over the disk. So indeed, that makes sense to me. Question 10. Which factor is critical when designing a cloud-native DB solution for HA, high availability? Data normalization, distributed architecture, monolithic design, or static resource allocation? Okay. I kind of know a little bit about static versus dynamic resource allocation, but I don't think this has got anything to do with a cloud-native DB solution for HA. It's not going to be monolithic. It's probably B. Data normalization is a good thing anyway, but it's nothing to do with HA. It's going to be B, distributed architecture. Let's have a look. Exactly. Distributed architecture, essential for HA, allows a system to continue functioning even if one or more components fail. Indeed, like a multi-zone type architecture, or even multi-region. Great. So if you're still with me, if you're enjoying challenging yourself like this and doing this with me, then please just give this a like while you're watching and engaging in this. I'd appreciate that. Question 11. What is the primary role of a data lake in a cloud architecture? Is it A, to enforce strict data schema, to store structured data only, to provide a centralized repo for all types of data, to optimize OLTP transactions? I'm pretty sure I know it's already C, to provide a centralized repo for multiple types of data. I don't believe it's got anything to do with OLTP. I forget what the difference is, OLTP, OLAP, but it's got nothing to do with this. And it's definitely not for structured data only, and it's definitely not enforcing a strict schema. Is C. It better be. Yes, it is. A data lake serves a centralized repo that can store vast amounts of structured, semi-structured, and unstructured data. Yeah, indeed. And I think the idea is that the whole company can kind of be served by this thing, and there should be synergies and that type of thing. What little I know about data lakes. Question 12. When implementing DB sharding, what is a key consideration to ensure effective distribution of data? Data redundancy, hashing strategy, centralized management, fixed partition sizes. Okay, it's nothing to do with management. So sharding is like, yeah, it's hard to describe. It's a bit like having a kind of RAID array of hard drives, and you're spreading over multiple volumes or tables or pieces of infra or something like that, and you're getting performance gains. You can have kind of like parallel reads and stuff like that. I think that's my real layman's or terrible explanation. So to ensure effective distribution, well, you might get redundancy out of it, but I don't think that this in itself will ensure effective distribution. Maybe, I'm not sure. I don't think you need this. I don't know. I don't want to make too wild a guess and be so committed to my guess because I'm not sure. I think it might even be this hashing one. Let's see what the answer is. Indeed, it's hashing. Well-defined hashing is crucial for evenly distributing data across shards, preventing hotspots and ensuring balanced workloads. Okay, you want it balanced. You don't want one shard serving more than others. Indeed, interesting. I need to note to self. I need to read up on sharding again. I only know a little bit about it. Like, it's good to have. It's good to enable. Question 13. Which of the following is a challenge when using serverless database solutions? Scalability, cold start latency, cost efficiency, built-in redundancy. Okay. So I already think it's cold start latency because that is one of the challenges generally with using serverless technology. Is that they it can be a little bit slow to start. So it's not scalability because you can scale theoretically almost infinitely with serverless, and I mean cost efficiency is not a challenge. Serverless is cheap. Built-in redundancy. You know, I don't even know about serverless database. I only know about serverless like things like Lambda. So I actually don't know when it comes to databases that are serverless. In fact, I never even knew there was such a thing. I don't know if redundancy is a challenge or what. It feels like you might need to have more control and need some kind of server-based database in order to have redundancy. I think it's going to be B, cold start latency. Let's have a look. Indeed, cold start latency refers to delay experience when a serverless function is invoked for the first time, which can impact performance. Indeed. Question 14. What is the impact of CAP theorem in the design of distributed databases? The impact of it when it comes to designing distributed, it guarantees data consistency and availability, illustrates the trade-offs between consistency, availability, and partition tolerance, eliminates network latency issues, ensures data is always replicated. So with this one, right, I don't think there's any real working out. Like, you either know it or you don't, and I wasn't sure when it said the impact of, but basically it's asking for a definition. This is the definition. It's the trade-off between consistency, availability, and partition tolerance. And the other questions, they're just red herrings, they're tricks. I better be right. Yes, I am. CAP theorem states that in a distributed database, you can only achieve 2 of 3 guarantees: consistency, availability, and partition tolerance. That's the CAP theorem, indeed. Question 15. In cloud databases, what is the purpose of using a content delivery network, CDN, with an edge database? To encrypt sensitive data, to enhance offline capabilities, to reduce latency for end users, to facilitate data migration. Okay. Now, I've never heard of an edge database, but I know what a CDN is, right? You can cache at the edge. It will be quicker. It will reduce the load on the origin. So let's see if anything here rings a bell. To encrypt, nothing to do with that. To enhance offline capabilities, I don't even know I mean, if you're offline, how do you access a CDN? I don't really understand that. Unless somehow you were connected to it, it would be caching the origin, but I don't think this is right. To reduce latency for end users, it's got to be this. To facilitate data migration, no, nothing to do with migration. It's got to be C, reduce latency for end users. Let's have a look. 15. Answer is C. CDN with an edge database helps reduce latency by caching data closer to end users. Indeed. Improving access speed and performance. Indeed. And that's the case whether on the edge is a DB or anything, to be honest. So great. Question 16. Which data modeling technique is essential for optimizing a graph database? So if you don't know, a graph database stores relationships. It's kind of what you might think Facebook have graph databases to store all the details of your social network and who you're linked to, and you know who your connections of connections are, friends of friends, and that kind of thing. So it says here, which technique is essential for optimizing a graph DB? So you have a graph DB and you want to optimize it with a technique. Entity relationship modeling, triples and RDF, star schema, denormalization. Okay, I don't know. I think it probably won't be D, but honestly, I don't know. This is something I've never looked into, how a graph database works, and probably one of these would stick out immediately if I knew the subject. So let's see what the answer is. B. Triples and RDF resource description framework are fundamental for modeling relationships in a graph DB effectively. Triples and RDF. It just sounds rather bizarre, but I'm curious already. Question 17. What is the main advantage of using a hybrid cloud database architecture? So I think hybrid meaning on-prem and cloud. Is it A, simplified data migration, improved security through isolation, better performance than a single cloud provider, reduced operational costs? So hybrid, on-prem, hybrid cloud. Well, they call it hybrid cloud, but I think they mean on-prem and cloud database architecture. Simplify migration. I don't really see how migration could possibly be simplified if you're running in two locations, in your on-prem and in the cloud. Improve security through isolation. Irrelevant. Better performance than a single cloud provider. Not really sure how. D, reduced operational costs. I don't really see how. You've got two things to manage now. I have no idea, and I think this question is not worded very well, but interested to see what the explanation is. See, it says a hybrid cloud DB architecture combines on-prem and cloud, indeed, allowing orgs to optimize performance by utilizing the best features of both environments. That's a really BS answer. I mean, it is kind of. It's like a manager answer. A C-level answer for someone who doesn't really know cloud. But it doesn't matter. Sometimes you get crap questions, right? So we'll take that in our stride. Question 18. In a cloud database context, what does the term data gravity refer to? Interesting. I don't know the answer to this. Is it A, the weight of data in storage? B, the tendency of the data to attract applications and services? C, the physical location of data centers? Or D, the speed of data retrieval? I'm gonna take a wild guess. It kind of sounds like I don't know actually. I don't know. I was gonna say C and D are ridiculous, and maybe it's A, but what does that even mean? Weight of data? I don't even know what that means. So let's not think too much. Let's just see what the definition is. I thought it might be B. Data gravity refers to the phenomenon where large volumes of data attract applications and services to deploy nearby, influencing architectural decisions. Large volumes of data attract apps and services to be deployed. Well, what does that mean? Does that mean like you set up, for example, a data lake and lots of teams in the company get attracted to using it and therefore it's a success? Is that what that means? I don't know. I'm going to have to look up data gravity after. Obviously, it means something. And if you're a cloud database architect / engineer, you're kind of expected to know. So note to self, look up data gravity. Alright, second to last question, number 19. What is the purpose of using a database proxy in cloud database architectures? A, to store backup data. B, to provide a single point of access for multiple databases. C, to handle data encryption. Or D, to manage user authentication. I don't know. I wasn't familiar there was such a thing called a database proxy. My best guess is going to be that it's B. provide a single point of access for multiple DBs. I can't believe it's A. I can't believe it's C. I can't believe it's D. Those are very specific use cases, and I don't know why you'd call it a proxy, but I don't know. Pure guess, right? Let's see what the answer. It indeed is B. A DB proxy acts as an intermediary providing a single point of access and load balancing. Makes sense. It's kind of like a network proxy, right? And load balancing for multiple databases, enhancing scalability and management. Yeah, that makes sense. Final question, number 20. Which approach is best for ensuring compliance with data protection regulations in a cloud database? Okay, so A, use of only public cloud services. B, regular data archiving. C, implement encryption and access controls. D, store all sensitive data in a single location. Okay, the first one, D, I mean, it might make sense to store your most sensitive data in one place and then kind of barricade it as if it were like Fort Knox. But I don't know in information security whether it's good to actually put sensitive data in one place or to spread it out. It might reduce your security if you're only focused on one place, but I can't believe, I've never even heard of this being a thing in information security. It might be. So ensuring compliance with data protection regulations in a cloud database. So use of only public cloud services. No, I don't think that's true. I think public cloud has a lot of nice kind of built-in stuff, and it is in some ways easier to comply because they're ready for that. Some of it will happen out of the box. Okay, B, regular data archiving. That's just good. That's good practice, but it's not really an approach. C, implementing encryption and access controls. I would say it's C. I mean, encryption should be on everything anyway. Data at rest, in transit, it doesn't matter. Everything should be encrypted these days, and that's easy to do in the cloud. But access controls, I think, is maybe what they're getting at. If you got a cloud database, how are you compliant with data protection regulations? It's got to be access control. So let me see. It's going to be C or D, but I think it's C. Indeed, implementing encryption and robust access is essential. Yeah, it just says that's the answer. So yeah, I was right. So that was 20 cloud database solutions architect / engineer test / interview questions. I hope you really enjoyed that. How did you fare? How did you score? Let me know down below. If you enjoy doing this, please give this a like and have a look around. I have other similar test / interview questions as well. And thank you again for joining me on this challenge. I enjoyed it a lot. I will see you again soon. Take care. Bye-bye.